Good morning. This is your Stats Sensei, Mr. Spensei, and this is a warm-up comparing the normal distribution to the distribution of means. So, a survey determined that the mean monthly rent for apartments in an urban area is 1,600 with a standard deviation of 400. I'm going to go ahead and make a note of that. Mean of 1,600, standard deviation of 400, standard deviation of the population. Label the mean and standard deviations as well as the z-scores for the apartment rents. Be certain to include the percentages associated with the empirical rule. So we've been doing the empirical rule for a while. Let's do that part first. We should know it by now. This would be 0, 1, 2, 3, because the mean of a z-score is 0. And please remember, this goes all the way out to positive infinity. All right. And then conversely, we have our negative z-scores, -1, -2, -3. And this goes out theoretically to negative infinity. And what we have here in the blue represent our z-scores. And the distance between each one of those is our standard deviation of 1. We also know that between plus or minus 1 standard deviations as an approximation is about 68%. Plus or minus 2 is 95%. And then plus or minus 3 is approximately 99.7%. The calculator can give you a more accurate estimate, but 99, those are the values that you should have memorized by now for the empirical rule. All right. We said we had a mean of 1,600. So our actual mean, this is our actual values, are done in red on this video. And we have a standard deviation of 400, which means every single step is changing by 400. So this would be 2,000. This will be 2,400. And this will be 2,800 at 3 standard deviations above. We also have to take away 400 if we're going down a single standard deviation or for each standard deviation. So 1,600 minus 400 is 1,200. 1,200 minus 400 is 800. And then 800 minus 400 is 400. So we're 99% sure, 99.7% sure that the actual values lie between 99.7% of the data is between 4,400 and 2,800. 95% is between 800 and 2,400, and 68% is between 1,200 and 2,000. Please remember the empirical rule only applies to the normal distribution, but it does apply to all normal distributions. So the empirical rule applies to all normal distributions, but only to normal distributions. All right. Part B is a continuation. So I'm going to go ahead and recopy my population down. So the mean of X, mean is 1,600. And our standard deviation for the population is 400. All right. It says illustrate the empirical rule for the sampling distribution of the mean apartment rents. Well, it didn't tell us how many apartment rents we were supposed to have, but let's just act like we had 20. All right. So let's act like we had a sample size of 20. I know it doesn't show it on this paper, but we'll adjust that. So we have a sample size of 20, and it wants the sampling distribution of the mean apartment rents, label the mean and standard deviations as well as the z-scores, and include the percentages associated with the empirical rule. Well, I'm going to start off again with the easy part, which is our z-scores. Our z-scores are still the same: 0, 1, 2, 3, all the way to positive infinity. This is a z-score. -1, -2, -3, all the way to negative infinity. And once again, plus or minus 1 is 68%. Plus or minus 2 is 95%. And plus or minus 3 is 99.7% approximately. And I should make a note, and I'm going to do this time. All z-scores, z-scores, all z-scores for the normal have a mean equal to 0 and a standard deviation equal to 1, which is why we're just changing by 1 as we look at this. All right. But it says label the mean and standard deviations as well as the z-scores and include the percentages associated with the empirical rule. You know what? I'm going to go ahead and change that sample size from 20 to 25, just because that's kind of consistent with what we have below there. It doesn't matter, but that'll work well. So we have a sample size of 25. Well, first off, the mean is the mean is the mean. So that part is piece of cake. All right. It's 400 regardless. All right. The mean doesn't change. So it says, what is the sampling distribution of the mean for apartment rent? Well, the mean equals the mean of X bar. And what we're looking for is the mean of X bar. And the mean of X bar equals the population mean, which is 400. We just showed that. Piece of cake, no issue. Before we get into actually showing the standard deviation, we're going to need some work. Well, the standard deviation of X bar, in other words, the standard deviation of the means, standard deviation of X bar is equal to the standard deviation of the population divided by the square root of n. Well, earlier we said the standard deviation of the population was 400, and they gave us a sample size of 25. So 400 divided by the square root of 25, which is 400 divided by 5, which in this case is 80. So the standard deviation of X bar equals 80. All right. So now we know that 80, that means we're changing by 80 at each one of these intervals. Whether we're going up or if we are going down, it remains the same. It's changing by 80. So this becomes 480. This becomes 560. This becomes 640. Going the other way, this becomes 320. This becomes 240. And this becomes 160. All right. And so the red marks are actual values. The blue marks are z-scores. Please remember the standard deviation of the mean is the mean is the mean. That's easy. But the standard deviation of X bar, or the standard deviation of the sampling distribution, is the standard deviation of the population divided by the square root of n. All right. I hope this was helpful for you and look forward to seeing you on the next one. Thank you.